Imagine you're falling, not toward Earth, toward Jupiter. You have about 2 minutes before anything happens to you, and what happens next isn't an explosion. It's not fire. Your body starts changing shape before you're anywhere near the surface because Jupiter doesn't really have one. This is what actually happens when you fall into every planet in our solar system, and by the end of this list, you'll never look at the night sky the same way again. Let's start from the beginning, with the planet closest to the Sun, and work our way out. Mercury looks like it should be the hottest death imaginable. It isn't. In 1974, the Mariner 10 spacecraft skimmed past its surface and sent back images that made scientists go quiet. The planet wasn't glowing white hot the way everyone assumed. It was scarred, ashen, and airless, a world that looked more like our own moon than a planet baking next to a star. Mercury has almost no atmosphere at all, which means nothing slows you down on the way in, and nothing keeps you breathing once you're there. You'd suffocate in seconds long before you ever reach the ground. And the ground itself is a contradiction. The day side can reach 800 degrees Fahrenheit, hot enough to melt certain metals. The night side drops to nearly 300 below zero. On Mercury, you could die of heat and cold within the same hour standing on the same rock because the planet has no air to carry warmth from one side to the other. Venus is worse, and it's not close. The pressure at the surface is over 90 times what you feel on Earth. The same crushing force you'd experience almost a mile underwater. Your rib cage wouldn't survive the descent. Neither would your lungs. And even if pressure alone didn't kill you, the clouds would. Venus is wrapped in clouds of sulfuric acid, dense enough to dissolve exposed skin on contact before you're even close to the surface. The surface temperature sits at 900 degrees Fahrenheit, hot enough to melt lead, hotter than any other planet in the solar system, including Mercury, despite Venus being twice as far from the Sun. The Soviet Union landed several probes there in the 1970s and 80s. The longest one survived just over 2 hours before the heat and pressure destroyed it completely. You wouldn't get anywhere close to that long. Mars is the one everyone assumes is survivable. For a moment, it almost is. The atmosphere is real, thin, but real, so you'd actually slow down as you fell, like a parachute that barely works instead of not working at all. That's the good news, if you can call it that. The bad news is that thin atmosphere is less than 1% the pressure of Earth's, roughly the same pressure you'd find 20 miles above our own planet's surface. At that pressure, your blood starts to boil at normal body temperature. Not because it's hot, but because there isn't enough pressure left to keep it liquid. Doctors call this ebulism, and it's one of the reasons spacesuits exist in the first place. You'd lose consciousness in under 15 seconds, and death would follow shortly after. It's the quietest death on this list, and somehow that makes it worse. Uranus doesn't even give you a surface to dread. It's an ice giant, which means underneath the outer atmosphere there's no solid ground at all, just a thick, freezing slush of water, ammonia, and methane that gets denser and denser the deeper you go, until it's technically still liquid, but nothing like water anymore. The temperature at the cloud tops is around minus 370 degrees Fahrenheit, one of the coldest points in the entire solar system. Colder than any spot ever recorded on Earth. Colder even than Neptune despite sitting closer to the Sun. Scientists still aren't entirely sure why. You wouldn't land on Uranus. You'd sink into it, freezing and losing consciousness long before you reached anything resembling a bottom, because there may not be one to reach at all. Neptune is Uranus's darker twin, and its winds are the fastest ever recorded anywhere in the solar system, clocked at over 1,200 miles an hour, faster than the speed of sound. Falling into Neptune, you wouldn't just sink the way you would on Uranus. You'd be torn sideways by wind shear violent enough to rip apart the fastest jet ever built. Voyager 2 flew past in 1989, the only spacecraft that has ever gotten close and gave us the only real look we have. What it found was a deep blue world with no solid ground anywhere, just storms the size of Earth itself, rotating endlessly in an atmosphere that never once stops moving. Saturn looks the gentlest of all of them. Rings and all, it isn't. Saturn is made almost entirely of hydrogen and helium, so light that if you could find an ocean big enough, Saturn would actually float on top of it, the only planet in our solar system that could. But that lightness doesn't mean softness. As you fell deeper, the pressure would build gradually at first, then catastrophically, until the hydrogen around you stopped behaving like a gas and started behaving like something closer to a liquid metal, conducting electricity the way Mercury does. You wouldn't hit a surface. You'd be crushed into the planet itself, layer by layer, dissolving into the same material Saturn is made of, somewhere inside a world that has no bottom to speak of. And now, Jupiter. Jupiter is the largest planet in our solar system, more than twice the mass of every other planet combined. And it doesn't have a surface either, not really. If you fell in, you'd survive the first 2 minutes falling through clouds of ammonia ice, watching storms larger than Earth roll beneath you, including the Great Red Spot, a storm that's been raging for at least 190 years since astronomers first recorded it in 1830 and is still going right now as you watch this. But the deeper you go, the atmosphere stops being an atmosphere. The hydrogen gets compressed so violently that it turns into a liquid, then eventually into something called metallic hydrogen, a state of matter that barely exists anywhere else in the known universe, one that scientists have only ever recreated in a lab for a fraction of a second. Your body wouldn't hit anything solid. It would just keep getting compressed, layer by layer, hotter and denser, until the pressure and heat did what no impact ever could. Here's the part almost nobody talks about. Every single one of these deaths is different. Cold, crushing, acidic, airless, but they all trace back to the exact same missing thing: a surface. Earth is one of the only places in the entire solar system where falling ends the way your body expects it to, with a single, sudden impact. Everywhere else, the planet either has no ground to stop you at all, or the ground is buried under conditions so extreme that they end you long before you'd ever get the chance to reach it. 4 planets in this solar system don't even technically have a surface. You could fall toward them forever in a sense if the pressure and heat didn't end that fall for you first. Line them up and the pattern gets stranger. Mercury and Mars kill you through absence. No air, no pressure, nothing to hold you together. Venus kills you through excess. Too much heat, too much weight pressing in from every side. And the 4 giants don't really kill you at all, in the traditional sense. They just never let you stop falling, compressing you slowly into whatever they're made of until there's no meaningful difference between you and the planet anymore. Rank them by how long you'd actually stay conscious, and the order flips almost every assumption you'd walk in with. Mars, the planet that looks the friendliest, kills you the fastest in under 15 seconds. Jupiter, the planet that looks the most violent, is the one that lets you live the longest, falling for minutes through clouds before the pressure ever catches up to you. We built our entire intuition about falling and about dying around one planet's rules. Earth has just enough atmosphere to slow you down, just enough gravity to make impact survivable in rare cases, just enough solid ground to actually land on. It feels like the default, the way falling is supposed to work. It isn't. Out of every planet in this solar system, Earth might be the only one that plays fair. Everywhere else, the rules you've spent your whole life assuming just don't apply. So the next time you look up at a planet's dot in the night sky, sitting there quietly among the stars, remember what's actually underneath those clouds. Not a surface, not a landing, just pressure. Building the deeper you go, layer after layer, on a world that never gives you a single place to stop falling.